talk about that. Hello guys, my name is Thomas and welcome to Mr. Padaku. If you like this video, don't forget to hit the like button, and if you like my content and want to support it, consider subscribe. So let's get started. Today on Phenomena Explained, we are going to talk about energy. What is energy, where it comes from, what can you do with it, we are going to talk about everything. So what is energy? Energy is the ability of an object to do work. If you can do any kind of work, a work in the form of thermal, in the form of heat, or in terms of giving motion to an object, you have some amount of energy. Now, where is energy? Energy is in every corner of the universe. Even if you take a vacuum, there is still energy. Scientists have measured the amount of energy in empty space, and it has come to be around 10 raised to the power minus 9 joules. Well, that's very, very small, but it's not empty. So it's not a complete void, and there's some amount of energy in the emptiness of space. Now, what kind of energy could there? There are many types of energy, and basically the energy is classified into 14 different types. So let's talk about it. First, you have mechanical energy. If you are running, so you have kinetic energy. And if you are standing on a mountain, you have potential energy. Now, kinetic energy and potential energy are together called as mechanical energy. So, if you are rotating or if you are walking, you have some amount of kinetic energy, and if you are climbing on a mountain, you are gaining potential energy. So, this constitutes mechanical energy. Number 2, you have electric energy. If there is an electric field, the energy stored in the electric field is called electric energy. Number 3, magnetic energy. The energy stored in a magnetic field produced by a magnet or any other object is called magnetic energy. Number 4, now you see that the earth is placed at a particular distance from the sun and it doesn't go flying off. Well, that is due to gravity or gravitational force between them. Well, due to the force, there is some amount of energy, which is called gravitational energy. So, the potential energy due to gravitational fields is called gravitational energy. Number 5. If you take a water molecule, you have 2 hydrogen atoms and 1 oxygen atom. Now, what is keeping them together? Well, they have chemical bonds between them, which are keeping them together. This bond has some amount of energy, which is called as chemical energy. So, whenever a bond breaks or is created, energy which is stored in the bonds is called chemical energy. Number 6. You may have seen a solar panel. So, as light falls on it, an electron is released, which hence produces the current. Well, the energy which is used to eject the electron from the atom is called ionization energy. Number 7. Nuclear energy. The energy which is stored in nuclear fusions and nuclear fissions in large nuclear reactors is called nuclear energy. Number 8 is chromodynamic energy. The nucleus of an atom consists of protons and neutrons. Well, the protons consist of quarks. Well, the energy which keeps these quarks together is called chromodynamic energy. Number 9. Elastic energy. When an object undergoes deformation and it regains its original state, the energy which is used is called elastic energy. Number 10. Mechanical wave energy. So when there's deformation in the particle, there's some amount of kinetic and potential energy. So this the sum of the kinetic and potential energy is called the mechanical wave energy. Number 11. Sound wave energy. When sound passes through a solid, the kinetic and potential energy due to the sound wave is called sound wave energy. Number 12. The energy stored in electromagnetic radiation such as light are called radiant energy. Number 13. Thermal energy. the energy possessed by a hot or a cold body with respect to its temperature is called thermal energy. It is the kinetic energy of the microscopic particles of the substance. And last and foremost, we have rest energy. This would be a surprise, but an object at rest has some amount of energy. We'll talk about how that mass has rest energy. So now you understand what are the different forms of energy. But you may have noticed that energy can be changed from one form to another. If you roll a ball, you give some amount of kinetic energy to it, and as it slowly rolls, it stops. Why does it stop? The kinetic energy of the ball decreases. Well, where is the energy going? Well, the kinetic energy is converted into majorly two different places. First is the thermal energy. As the ball is rolling, it is creating friction between the surface of the ball and the floor, which creates heat, which in turn creates thermal energy. And as you are rolling the ball across the table, there's some sound which is produced. So you have sound wave energy. So now you see that energy is being converted from one form to another. But you will notice that no energy is destroyed. What is happening here is that energy is always conserved in the initial state as well as the final state of the object. So no matter what kind of process you are running, the energy before and after would be constant. But there was an anomaly in this law. When scientists observed nuclear fusion or nuclear fission, they noticed that there is some discrepancy in the amount of energy which is before and after the process. So if you take nuclear fission, what you see is that a larger nuclei is hit by a small neutron, and the larger nuclei splits into smaller nuclei. Now, according to the law of conservation of mass, the mass of the particles before should be equal to the total mass after. Was this true? Well, no. What happened is that the total mass after the process was lesser than the total mass before. So where did that mass go? Well, that mass is converted into nuclear energy. So here you are seeing that some amount of the mass from the larger nuclei is being converted into energy. So the mass converting into energy, well, we haven't talked about that. Well, that is what Einstein had found. He found the relation between the mass and the energy. So his most popular formula, E is equal to mc square, explains the relation between the mass and the energy. So here C is the speed of light, m is the mass of the object, and E is the energy it would produce. So this led to the formation of the law called the law of conservation of mass and energy. Total amount of mass and energy before and after would be constant. So now you understand that mass can be converted into energy. But can it be the other way around? Well, if you have seen Star Trek, they use a system for teleportation. While they are standing on the platform, what Spock says is that he says energize. Well, what does that mean? Here, the mass of his body is being converted into energy, and at its destination, it's being converted back to its mass. Now, this is a very futuristic technology, but there is still a lot of research going on about it. Because imagine that you have no runways or you don't have any aeroplanes or cars. You just have a simple cable joining two locations, and you are just standing in a platform and instantly you are transported at another point. No traffic, no anything. Just imagine how great would it be. So now we understand what is energy, what are the different forms of energy, how is energy always conserved, and how is it converted into different, and how is mass related to energy. So I suppose that the phenomena of energy has been explained. So that's been my time, guys. Never stop learning. If you like this video, don't forget to hit the like button, and if you like my content and want to support it, consider subscribe. Mr. Padaku signing.